Hello YouTubers! Welcome back to another episode. Today we are going to be writing a program that draws a spirograph. A spirograph is something you can buy at Walgreens or Amazon that allows you to draw these cool patterns, and it consists of a small gear with teeth on the outside and a large circle with teeth on the inside. And basically you place the small gear into the big circle and you put a pencil in one of the available holes and you just start drawing as you trace this small circle around the big circle, and it creates these really cool patterns. So we're going to get into the math of the spirograph and how this actually happens, and then we're going to write a code that allows the drawing of a spirograph. And so it's pretty cool. So the first thing we're going to discuss is the math and what parameters you need to provide the program to be able to draw the spirograph. But then after that, we will be writing this code that does this. So this is drawing a spirograph based on the parameters of the input file provided by the user. Basically, you specify the color and the line width and a bunch of the required numerical parameters, and it draws this cool pattern, which is a spirograph. And you can specify multiple spirographs with different parameters and different colors and draw them on top of each other when you hit the return key. So I'm going to do that now because I have a second one specified. So now it's drawing a second one over the first one. And the point is, you can have this program can draw a bunch of really cool patterns for you, and you can it's basically develop some really awesome artwork and maybe give it to your family or friends. And yeah, and it's a very simple code that's about 100 lines of C++. And yeah, so let's get started now. Okay, so first we are going to discuss the math of the spirograph, the spiromath, so to speak. So this is a cartoon depiction which includes all of the variables relative to the spirograph. 5 of these variables are initialized by the user. These are the specifications of a given spirograph, and these are constants that don't change. So those variables are Cx and Cy, which are basically the center location of the spirograph. Capital R, which is the distance between the center of the big circle and the center of the small circle. Little r, which is the distance between the center of the small circle and the location of the pencil. And finally, little d, which is the diameter of the small circle. The rest of the variables are so-called dynamic variables. These variables change in time. So as you saw from the original run of my program, the image is constantly changing as time goes on. It's supposed to model drawing the spirograph. So there are a bunch of dynamic variables because of that. So I have 2 angles that I'm calling big theta and little theta, capital theta and lowercase theta, and these change dynamically. And then I also have capital X, capital Y, lowercase x, and lowercase y, which also change dynamically, and they are the center location of the big circle and the location of the pencil, and these depend on the thetas. So every time step, the thetas are updated. So big theta is updated by a small number, which I'm calling I here, but I think in the program is actually called d theta, which actually makes more sense. And then little theta is updated accordingly by this mathematical relationship. And one thing to notice is that every time step theta actually increases, but big theta increases, but lowercase theta actually decreases. Now, why is this? So if you imagine yourself having this pencil here and you're drawing the spirograph, this big R vector is actually going counterclockwise. But if you look at the direction that little x, little y is going around the center of the small circle, it's actually going clockwise. So you have one thing that's rotating counterclockwise, and the other thing is rotating clockwise. So in the real world, these are always rotating in opposite directions. This is rotating in this direction while this is rotating in this direction. I actually allow the user to toggle this in the program. You can actually draw a spirograph where both the thetas are updated by a positive number, and this can't be done physically in the real world. This is an unphysical phenomenon, but you can actually change the sign and see what happens, because this is a simulation and we have the power to do that. So after these thetas are updated, then these coordinates are updated accordingly with the new values of the thetas, and that's how the program works. That's the core engine of the spirograph. So let's get into it. Let's start writing this code. Like I said, or did I say this before? It's a really short code. It's 100 lines of C++. Yeah, so let's get into it. Let's start writing. Okay, so I am using C++ with a library called SFML to develop this. So make sure you have, and I'm using the G++ compiler, so make sure you have the proper compiler and you have this library up and running. There's tons of documentation online for how to get that started. I'm doing this personally in Ubuntu Linux using the Windows subsystem for Linux, but however you want to do it is fine. And my text editor is called Sublime Text. Okay. So the first thing you want to do is create a working directory and create a text file in that working directory. I'm calling it inp.txt, which is meaning it's the spirograph input file. And the spirograph input file is going to look like this. R, little r, D, capital R, CX, CY, red, green, blue, sign, width. So these are the input parameters that I spoke about earlier. If you don't remember what these represent, you can go back, you can rewind and see. RGB specifies the color. I'm not sure if you know this, but any color can be specified as a linear combination of red, green, and blue. And these take values from 0 to 255. The higher the number, the more you get of that color. So 255, 0, 0 would be very red, and that's it. It would just be red. Black is 0, 0, 0, and white is 255, 255, 255. The sign, this is how you toggle plus or minus, like I was talking about earlier. How you can make how the change in little theta depends on the change in big theta. And finally, the width. This is the width of the pencil, so you can make the spirograph thicker or thinner with this number. So I'm going to copy some values from my original input file, because I know that these make really nice spirographs. So we're going to use these values, and I'm going to save this file again. Okay, so now let's get into the code. So I'm going to make a new file in my working directory. I'm going to call it spiro.cpp. .cpp is a C++ file extension. So I have to include a bunch of libraries here. IOStream. I'm just going to copy and paste these because this is actually kind of boring. These are just libraries I have to include. Let me zoom in. Okay, so the first thing we want to create is a string splitting function. So this function is going to be necessary for basically parsing the input file. I think I'll copy and paste this one too. So I'm calling this function split2. It takes a string as an input. And then it also takes a vector of strings, and finally a delimiter. So the delimiter is the type of character that separates the other characters in the file. So you can see that all of these parameters are separated by spaces in my input file. So that's why this is the delimiter. And then I'm creating a string stream, which belongs to the namespace std, and it's called ss. And I'm feeding this string into it that was originally read into here. And then I create another string called token. So basically wait a second. Right. So I see what I'm doing. So this string that's input into the function comes from the input file. So this string str, depending on what line you're on, maybe it would be this line here. So this is what's stored in str. And it's a string stream. It's converted to a string stream. And then what you do is you loop over the string stream in increments that are separated by the delimiter. So it goes, so one iteration of the loop collects this data, then it collects this, then it collects this. So every single iteration, it's collecting a piece of data from the string stream. And what it's doing is it's storing it in this vector of strings called cont. So what that means is, so this is a vector of strings, and it's when you have a vector, this function called pushback basically appends something to the vector. So token is the string that's stored from the current iteration over ss. So token would store like 200 or 400 depending on where you are, and then you basically append that to cont. So basically at the end of this function, cont has been updated to contain every single piece of data from the input file as a separate entity, basically. So you have a vector of strings. Each string in that vector is an input parameter from the input file. And that's what this does. And these ampersands are basically saying pass by reference, which means whatever you pass into this function gets manipulated directly, which is good. So I'm passing something in here, and I want it to come out of the function having all of the input data from the input file. Okay, so that's a function we need. Now we're going to jump straight into the main code. So the main code is going to use this function, and I wanted to develop it right off the bat. So let's start our main function. So this argc and argv stuff is functionality that allows us to use command line arguments. If you remember when I ran this code at the very beginning of the video, I don't know, actually, maybe I don't think I showed that, but it's it'll be /spiro to run it, and then you need it takes the name of the input file as a command line argument. So I need this functionality to be able to do that. So I have a bunch of input parameters, next pattern, which I initialize to false. You'll see what that does. You'll see what all of these things do once we start actually getting in the code. When x equals 800, when y equals 600. These are like the dimensions of the screen. Whoops. Width, temp x, temp y, counter, red, green, blue. These are all variables I need. Whoops. Cx, cy, x. I think you remember these. Y, x, y, r, d, r, theta, theta, d theta, temp. std string, line 2, sign, and you'll see what those are soon, eventually. Std vector. So now I'm creating a vector of strings called vline, and you'll see what all these do in a little bit. So now I'm going to initialize the thetas. So I'm going to initialize them both to be 0. And then I'm going to create the main window. So SF is the SFML namespace, and this is the library we're using to do all the graphical stuff. So render window. So I have a window. I have a variable called window that is a SFML render window object. SF video mode win X, win Y. And win X and win Y are the dimensions of my window. The X and Y dimensions, the number of pixels. And finally, I have some sort of title that's going to appear at the top of the window, in the place where you can grab the window and move it around. I'm just going to call it Spirograph. So now I create a pixel array, unsigned integer. I'm going to call it pixels equals new SFUINT8 win X times win Y times 4. So what exactly is this? So in SFML, the pixels are defined with a pixel array. So let me do an illustration to demonstrate what this is real quick. So let's say I have I have 800 by 600 pixels in my program, but let's say I only have 3 by 4, win X times win Y, and I create this pixel array, which is win X times win Y times 4. So that's how many elements this array has. So in the case of this, I have 12 times 4. I have 48 elements in this array. And each of these stores a property of each pixel. So all the pixels have 4 properties, hence the 4. Red, green, blue, and like opacity or something. I don't remember what the fourth number means. I think I just by default set it to 0. But in any case, those define the color of that pixel. And so the 0, 0, 0 element of this array is the red component of this first pixel. And this pixel contains data in the 0, 1, 2, 3. The first 4 elements are for this pixel. The next 4 elements are for this pixel. The next 4 elements, are for this pixel. And then it goes to this pixel, and so that's how it works. So each of these pixels has 4 values, and it goes from left to right, and then it goes to the next row and left to right. And so all the data for required to draw all the pixels in the proper color is stored in this pixel array, and that's how it works in SFML. The next thing I want to create is an SFML texture. Honestly, I'm not even quite sure what this does, but you need it to get your image. And then I do texture.create win X, win Y. And finally, I create an sprite called sprite, and in it I store texture. And all this stuff is what you need to basically draw the graphic to the screen. And there's a whole bunch of theory behind it, and you can go and read the SFML literature if you're interested in that. But I want the main focus of this video to be the spirograph. So let's continue here without going too into detail of what all this SFML stuff actually does. 1 second here. Okay. So next, I want to initialize all pixels to black. So I'm going to populate this pixel array. So what I'm going to do is I'm going to loop over this variable called I, an integer variable called I, while I is less than win X times win Y times 4. and then I say I plus equals 4. So basically I'm going through all of the pixel arrays, but I'm jumping. I start at 0, then I go to 4, then I go to 8, etc. And I populate everything. So pixels I equals 0. So I'm setting red to 0, and I'm also going to set green and blue to 0. I'm just going to copy and paste these though. So I've set green to 0, and I've set blue to 0, and I've set this fourth parameter to 255, and I'm not quite sure what that is. I don't really remember. But yeah, so 0, 0, 0 is black, and then it's going to go to the next pixel, and it's going to loop over all of the pixels on the screen, and it's going to set them all to black. So that's what this does. Set my counter to 0. You'll see what that does in a little bit. And now read the first, line in the input file. So now I create an input stream, if stream, and I'm going to call it inp, and it's going to take a file name. And remember, the input file name is the first command line argument. So that's what arg1 means. So I'm opening up an input file called inp with this file name. That's a command line argument specified by the user. And then I do std get line inp line. So basically, I'm storing the line of this input file, the first line, in this variable called line. I actually want to skip the first line, the very first line, because the very first line is just it's an indicator line that tells the user what each variable corresponds to in what order. So I want to do this again, std get line inp line, the real first line of the input. So this is the real first line, which specifies a bunch of parameters for a spirograph. So now what I want to do is call split2. If you remember, I wrote this function earlier, line vline. So if you remember split2, it takes a string, which is a line in the input file, and it's called line. So I read line in from my input file, and now I'm passing it into split2. And the second parameter, if you remember, is a vector of strings. And that's what vline was declared as earlier. So here we have a vector of std strings called vline. And that's being passed in here. And so that's being populated with every single argument of the input file separately. So next I want to populate my variables with the data I've just extracted from the input file. So little r equals, I'm converting to a double from a string. So I'm converting a string to a double. And I say vline 0. So because so basically the very first element in vline corresponds to little r, and you can see that in the input file. Little r is the first, and then it's going to be dr, cx, etc. So I'm just going to say d equals sto, convert to double, vline 1, and I'm just going to copy and paste the rest of this, and then I can explain it. Let's see. So red, I'm converting to an integer, because red, green, and blue are integers, 0, 1, 2, up to 255 for each value, red, green, and blue. And then I have sign. The sign is plus or minus. M or P is the way I have it here. And remember, that's the sign that specifies which direction little theta updates in, which way the circle is drawn. And then finally, the width is also a double. Actually, it should be an integer. Maybe it doesn't matter. The width is the final. So this is the width of the pencil. It's the thickness of the pencil. Okay. So now I have all my variables populated based on what the user wants. So now we're going to get into the main loop. I think I might, let's see, I'm going to copy and paste a little bit of this stuff. So this is just SFML stuff. This is the main loop. While the window is open, I have an SF event called event. This is what listens. It's kind of like a listener. It listens for key presses and stuff because if you remember, when the user presses return, it's saying to go to the next spirograph in the input file. And I have other buttons you can press that do other things, and we'll get into that right now actually. So I have, let's see. Actually, I want to change this a little, but let me just copy and paste it real quick. Poll event. So one thing I have here, so d theta is how much the angle increases every time step, and that determines how quickly your spirograph is drawn. And if it's too slow for your taste, you should be able to increase it. The issue is if you increase d theta too much, then it's going to be really sparse and it's not going to look like a continuous line. But maybe you care more about speed, or maybe you want the line to look even more continuous. So the idea was I wanted the user to be able to control this parameter. So theta. Oh, do I not have it defined here? D theta. Oh, I didn't define that. So I should first of all define that. It's supposed to be defined here. D theta equals pi over 500. So this is the change in theta in radians. If you don't know, 360 degrees, which is a full turn, is 2 pi radians. So this is pi over 500. So this is 1/1000th of a turn about the circle. So it's pretty small, but you could make it even smaller. And so I'm going to change this. I originally had it to where there was a small value and an even smaller value, but I kind of don't like that. I think it would be better if the user could actually increase this value and decrease this value at will. So let's see. Pi over 500. Maybe not. Maybe I should. Well, yeah. So let's say when you hit the right control button and it increases d theta by a small amount. Let's say pi over 10,000. It's interesting because it could go negative, or it could go to 0, but that's okay. Minus equals pi over 10,000. So basically, if the user hits the right control key, then d theta will increase by a small amount, and if they hit the left control key, it's going to decrease by a small amount. So this allows you to control the resolution of your image and also how fast the spirograph is drawn. I don't know if I've never tested this before, so we'll see how well this works. Maybe I should make it so that I'm gonna do something here. I'm gonna put some what do they call them? Bumpers, like in bowling. I'm gonna put some bumpers to prevent. I'm gonna say if dt is less than or equal is less than 0. That way, I don't think I want dt to go negative. That's weird. It'll start drawing it backwards, and it'll be retracing its steps, and that'll just look weird. So, worst case scenario, the user makes it so small that it just stops drawing, and then they have to go and increase it. Okay, so the next thing we want to do here is we want to make it so that if the user hits return, it will go to the next spirograph. So if event type equals SF event key pressed. If key So basically I'm saying here, if the user hits the return key, all I'm going to do here is I'm going to set, I'm going to set this next pattern, well, it's supposed to be called next pattern, to true. So this is a Boolean I created at the beginning, and it was set to false. And basically this specifies whether or not to go to the next pattern. And the reason I have it like this is because if you just press a key, it's hard to press it and the loop to only see it register one time, because this program is running at 60 frames per second. So if you hit return, it might just run through a bunch of skip through a bunch of your spirographs. So it has to be so that basically if you press the return key and then you release the return key, then it goes to the next pattern. Yeah, so it's to prevent that from happening, where you hold return key and it says, oh, you pressed return, you held return like 50 times, so we're going to go to the 50th spirograph, which is what you don't want. So I have another conditional in here, if event type equals SF event key released and next pattern. So basically, hitting the return key sets next pattern to true, which is saying go to the next pattern. Once the key is released and it sees that this variable is true, well, it has to check. Let me just copy and paste this. It has to check that it was the return key that was released. Now I want it to do everything. So the first thing I want to do is clear vline. Vline is what stores all my input parameters as read from the input file. And then I want to do std get line again. Input file, store in line. This is all the same code from the beginning that I showed you where we read everything. Then I call split to again. Line vline. And then I'm just going to copy and paste all this stuff. Then I reload all of my spirograph variables from the input file. And finally, I want to set next pattern to false again, because I don't want it to go to the next pattern in the next loop. So that's all the SFML stuff. Now we can get into the heart of this video, which is what you've all been waiting for, which is the actual Spirograph Engine. So I think that's where we want to be, right? This is the event. Okay. So the first thing I want to do is update the d theta. So I update theta. So I increase theta by d theta. And now I want to update little theta if sine equals minus theta equals theta minus dt times 2 times r over d. And then if it's plus, it's just becomes a plus. So this is the thing I was telling you, like, this is the, well, let me pull up the original image if I can find it. One sec. If you remember, I was saying how the circle the pencil that's going around the little circle is always going in the opposite direction that the little circle is going around the center of the big circle. And this sign here is negative as opposed to this being positive. But I said, that's physical reality. That's the negative case. But in my program, it can also be positive. And that creates a pattern as well that can't be done in real life. Okay, so let's move on now. So the next thing is I want to set x. I'm just going to leave these equations up here because it's cool to see this being realized in the code. So now I'm doing x and little x. Big X, big Y, little y. X equals Cx plus R times cosine theta. Y equals Cy plus R times sine theta. And then little x is equal to big X plus R times cosine of little theta. And y equals big Y plus R times sine of little theta. And then finally, I have to convert these values to integers, because this little x, little y tells you where the location of the pencil. And that's the thing that has to be drawn every single time this thing is getting updated. But the issue is that the location of the pencil is going to correspond to a location in this original pixel array that I created earlier. And this locations in the pixel array can only be specified as integer values, because you have location 1, location 2, location 3, etc. So I have to actually have integer versions of this. Temp x equals integer x. Temp y equals integer y. Whoops. And that creates, slight rounding errors and offsets, but that comes with the territory, and it still looks fine. So, okay. Okay, so now we're going to use this counter variable that I created earlier. So while counter is less than width. So basically, counter is being used to basically loop through the width of the pen. So you're basically coloring every single pixel on the screen at the location of the pencil, such that it's as wide as the user specifies, and that's what this kind of counter is for. So counter starts at 0 and it goes to width. So if width is 22 or 14 here, for example, then the width of the pencil is 14 pixels, and it has to loop over that width. It goes from 0 to width. So that's what we're doing here. So this is the actual changing of the pixel array, and we're going to get to that, and then we're going to get to the drawing, and then that'll basically be it. So we're almost done, actually. So I'm going to copy and paste. Well, not yet, actually. Oh yeah, I am going to copy and paste. Okay. So basically, I think this is checking if the I'm not positive, actually, but I think this is checking if the pencil is out of bounds. Yeah, because I think it's checking. It's because you don't want the spirograph to be drawn out of bounds. If you're actually off of the screen, then it just skips it. It just doesn't draw it. And I think that's what this does, but I'm not positive, and I'm not going to investigate. Okay, so I'm going to copy and paste again. So, oops. Okay, so what is this doing? So I'm setting, so this is basically, so temp x holds the x position and temp y holds the y position. And if you remember, I have a pixel array, and I go from left to right, and then I go to the next row, and then I go from left to right, and then I go to the next row. So temp y is basically the number of rows that I go down in the pixel array. Maybe I should draw this again, just to make it more visually clear. Yeah, I'm gonna draw it one more time. So pixel array, element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 6. So you see what I mean? So to get to the to the correct position in the pixel array, the first thing I do is I multiply temp y times 4. So temp y is basically the y position, and the y position is basically the number of rows down you have to go in the pixel array. So I multiply that by 4 because each pixel has 4 values in it. Red, green, blue, and other. So 4 times temp y takes me down to the proper row. So 4 times temp y times win x. So win x is the number of pixels in the x direction, and I times that by 4, which is the number of elements in a single row, times temp y, which is the number of rows, which that brings me to my y position. And now I have to move over to my x position. So I add 4 times temp x plus all this other stuff that's accounting for the width. And what this is doing is it makes it so that the pencil is centered at your current location, and the width is, you have half the width on the left and half the width on the right. And that's why I have this 0.5 times counter and all this other weird stuff. So that's what this is doing. This is setting the current pixel on the screen and the current set of pixels that correspond to where the pencil is drawing to the red, green, and blue specified by the user. So that's how that works. I hope that's clear. If not, you can download this on GitHub. I'll upload this to GitHub so that anyone can download this code and modify it themselves. And yeah, hopefully that'll be helpful. The next thing I want to do is window.clear. It's just an SFML requirement. Texture.update pixels. And finally, window.draw sprite. Oh, not finally, there's one more thing. There's 2 more things. Window.display. And then finally, at the very end of the program, when you finally close it, the input file is also closed. So that's all the code. It's 114 lines. Actually, I can make it even shorter because I don't think counter has to be initialized, set to 0 here. So it's 112 lines. So let's compile and run this now. Let's see if it works. Let's see if it works. So here we go. We're going to compile this now. So, oh, whoops, I'm in the wrong directory. Okay, so to compile this in Linux, I do g+++-c spiro.cpp. Okay, I have errors, of course. I think this is supposed to be argv1. And then also I have updat, texture.updat. It should be update. Okay, let's try again. Yeah, no matter what, even if you're literally rewriting code that you've already written that works, there's always going to be bugs. There's always going to be errors. So that's a fun lesson. Anyway, oh, whoops. Let's do it again. Okay. Let me just zoom in here. Whoops. Let's make this font as big as we can. You don't need to see the code anymore. Whoops. Okay. Let's try again. Oh, I did it. Okay. So what that did, I compiled this, and it creates an object file called spiro.o. I don't know, this elementary programming class now. Okay, so yeah, sorry, maybe I shouldn't. Okay, anyway. The next thing I want to do is convert my object file into an executable. So g++ spiro.o, that's the object file. I say -o, Spiro, so the executable will be called Spiro. And I have to put these LSFML tags in there so it knows I'm using LSFML. Window, graphics, one second. Some noise. LSFML-window, graphics, and system. So now it's compiled. So now you look, you see the object, the output, the executable here. So now I can do /spiro inp.txt, the input file, and I hit enter, and now it's working. So there you have it. We can just kind of watch this for a while as I talk a little bit more. Coding is fun, and you can do whatever you want with it. Yeah, I don't know what I'm trying to say here, but isn't this awesome? You can download this from the GitHub. I'll leave a link in the description. And yeah, I hit enter. That takes us to the next one. This is exactly what you saw at the beginning of the video. So yeah, you can download this program, and you can maybe mess with the input file, like make different spirographs with different colors and different radii and all these things, different widths. Maybe change the minus to a plus if you're feeling adventurous. And yeah, enjoy. I hope this works for you. Let me know in the comments if you've tried this and if you ran into any issues or how you're doing and with this and everything. Okay, anyway, I hope you all have a good day, and I hope you enjoyed this video. I'll talk to you later. Bye. Big shout out to Skopurbo, the artist who designed my thumbnail art. I'm really happy with the work, and I've linked his website and Pinterest in the description below. Thanks, Skopurbo.